Hello everyone. In this video I will walk you through defining an index lifecycle management policy for a time series index, and the second topic will be defining an index template that creates a new data stream. So these both are related. So what happens is, like, we have a time series data, the streaming data, for example information like a log server, a matrix, or a streaming data from some transactions that comes non-stop every second, and we create a lifecycle policy on that. And then after the index lifecycle policy, we can define a template that we can use to search for that particular data. So let's get started. So I have my slides open. So this is the today's topic. So I'll just quickly explain what is the index lifecycle management for the streaming data. So as you can see, data is coming in, and initially the data would be hot because it would be searched or updated on a very frequent basis. But after some time, for example 30 days or whatever, depending on the business requirement, it becomes warm, and that is accessed less frequently, and it rarely gets updated. And after some time, for example 3 months, 6 months, or a year, it becomes cold data, and that is accessed infrequently and not usually updated, and we can move the data to some other storage device. And finally the frozen. So at that point the data is not kept at node at all, and it can be archived to some like cold tier or something. So I'll just quickly read through the lines. So as I mentioned, hot tier, very recent data, logs or metrics, and which is most frequently accessed. And warm, less frequent and rarely updated. So these 2 points. Hot is both read and write is very frequent, and cold is very infrequent and not at all updated, or not usually updated, once in a while. And to save space, we can mount it to some other snapshot or some other storage device. And finally frozen, which is rarely and never updated. So it's like very after one year or something, and it can be like if it can be 20 times compared to warm tier, means access capacity can be this extend the storage capacity even further, so you can store 20 times more than the cold tier. Okay, so here's one example of my index lifecycle management policy. So I'll just quickly walk you through it. So here I have created one through the Kibana console, and this I'll show you, and then I will create a new one, and it will be exactly same as the first one, but this is done through the REST API. So as I mentioned, there are phases. So this is the first phase. So it's hot. So this is a keyword. So it's like immediately, minimum age 0 second means immediately it becomes hot, and there is a priority given, and there is if it becomes more than 50 GB or 30 days, whichever comes first, then it will roll over to the warm phase. And the warm phase, it will be there for 60 days. So first 30, then next 30 will be in the warm, and there is a certain priority which you can give. And finally the cold, which is after 90 days. And so they are actually data nodes which you can assign. You can label your data nodes in Elasticsearch with hot, warm and cold, and those data nodes, depending on their pricing and CPU storage performance, like one could be SSD, one could be hard disk, so you can and one could be archive or tape, so you can specify all those things. And for example, I have given frozen 1. So frozen is after like 120. I have given arbitrary number like the 30, 60, 90, 120, and I have put a snapshot repository, which is basically I'm storing it to file system, and it's no longer part of Elasticsearch nodes cluster. And these are my settings, and I'll just copy this. And first I'll show you, like, I created one policy through the Kibana console. So you come to stack management, index lifecycle management policy, and you can create, for example, if I come here, there are a couple of policies already there. So one I have created through the REST API and one through the UI. So you can just create a policy like this. So let me just show you how it looks like. So if you say create policy, you will see all these phases, and you can just click all these phases. And once you click all these phases, you can change like how many days, all those things you can play around with that. So it's an easier way to directly create it through the user interface. But anyway, for the exam, we should be knowing how to do it through the REST API. So I will paste that snippet of code. And first I will show you the one which I created through the UI. So it's the same thing which I will be creating now. And this is just have number 2. So this is ILM policy for data stream. So name you can give anything that you feel like. So it's created, and I can just confirm. So it's exactly the same thing. Okay, so once I have created the ILM policy, next dependent item which I have to create is index template. So index template is basically you give there's a REST endpoint index template name, and this is the name user defined. So I'm giving a name like index template for data stream, and then you have to specify index patterns. So index patterns are, in this case, index names can be time series or anything after that. No, in this case it's directly just exactly time series, and this one is important. So if you say data stream equal to this one, like then it becomes a data stream index template. If not, it will become a regular index template. And then you have some template settings. So you can, I've just given number of shards equal to 1 and all. And this part is important. And so this template is using that ILM policy which I have created in my previous step. And then I will just confirm whether it's created or not. So I'll copy this and go to DevTools. I'll create this policy. So index template has been created, and it's all good. Okay, moving on. So this is the last and final step. So herein, because index name I have specified a time series, so I'm just sending a doc, a record. It can be any kind of doc. It could be a complicated nested document, any JSON document that you want to send. And then you can just do like check out the index and search, and you can explain the time series, how the information is stored in and which phase it's going through. I will walk you through that. So I come here and paste that. So I'll send that record, and so this is my index. So you can see that index. So for the front end application, it will be time series, but internally how it's stored, it's slightly different. So it will follow the rules of index lifecycle management, because data is very fresh. So it will just go to the right node and all automatically, and it will be following the index lifecycle management policy, all those things. And that will be explained in the 4th step when I come to the explain API. And I can do a search. So I have put a lot of information already. So there are like 13 hits, and all my data is getting stored. So when you create any time series, this one, so it usually starts with .ds and then the index name, and then followed by dash star, and then ILM and explain. So herein I'll just try to explain. So herein you can see this is the index name behind the scenes, and it's a managed index, and the policy which it's using, that is a policy name, and there is an age. So it's like 45 minutes, and it will tell you which phase currently the data is hot, because I give 30 days, and it will tell you which step it's checking. So it will check for rollover, but rollover hasn't happened, and phase definition, all those things. So this is like internal information. So that's all we actually need to know for the for this particular topic. How to create index lifecycle management policies and the index templates for the time series data. So that's all I have got, and thanks for watching. Bye.